It's remarkable what we can analyze these days, be it the data of a DNA sequence, the number of coronavirus cases, the weather, climate change, economic relationships, and much more. With systems and programming capabilities extending to new heights every day, the technology for humanity and mankind has always been turning out fascinating. Today, let us explore the data outreach and correlative analysis of soil moisture and weather. We have devised an application that allows user to correlate and compare all sorts of data. Here, considering the soil moisture and weather data that's being used to portray. The home page shows a map that takes in user inputs for the desired location that they would require to start with. And since we have the land data embedded in the database, it would revoke users from clicking on water bodies, as the study that we proposed was on soil. Once the user clicks on the desired land area, the algorithm is triggered to search the database for data pertaining to that location. We have devised one of the fastest search techniques that efficiently searches more than 20 GB of raw data and then prepares the data for analysis. Meanwhile, in the front end, it would load an animation for the user to wait until the machine learning model has completed training and predictive analysis of the correlative variables. Once the data has been prepared, the results are then plotted with three parameters with the prediction and raw input for comparison. Similarly, the raw data can also be visualized in the visualization section of our application. We have the same three parameters, which each take a date for soil moisture and year for the precipitation and temperature. Now, choosing a particular date for soil moisture, on selecting a date and submitting, in a new tab, the soil moisture data is spread across to its corresponding coordinates in a unique color spectrum depicting variations. On hovering over a particular region, a pop-up would also depict the coordinates with the soil moisture index. A screenshot of the area can also be saved as a PNG file, and more tools like area selection in both rectangle and freeform can also help better manage the regional selection. Let's head back to the Visualize page. The temperature section would require the user to select the year of which they would like to visualize. On selecting a year and submitting, A GIF is generated and cycled through the days of one entire year, showing the temperature changes. Similarly, now giving the year for precipitation. Upon giving the input, each day of the selected year is cycled to give a visualization. Now heading on to the next section. Having the user's perspective, we have a description page for the user's context behind the application and the data used. It describes the techniques that we use to get the application up and running. And finally, the developers behind the project. Thank you.